as we go on to topic 1 of module 6 of the exercise set. We're going to take a look at our first set of items, make it a little bigger here for you, and that is to classify each of these 8 statements as to whether they're true or false, and then to give a support if needed. So let's go on. And by the way, there's 4 true and 4 false. So we'll pause. And we can see how you did. The first 2 are true, and the last 2 are true. The ones in the middle are all false. In looking at these, we say the composition of 2 functions f and g is written as f composed with g. And that is correct, and that's true. The notation f composed with g in regard to the x also means this. This is just another way of writing this. So both of these are equivalent. Now, as we look at number 3, here is our f function. There is our g function. But in this case, they're saying g composed with f. Now, if that were true based on these functions, that would not be the answer. But if you said f composed with g, that is, you reverse these, then this would be true. So that's why it's false. It's not g composed of f, it's f composed of g. For any function h, there is only one way to decompose the function. Actually, there's more than one way. So that's why this is false. The function f is 1-to-1 when it's in this particular pattern. Well, remember we said this can be converted to y, and we're saying y equals 1. So if we were to graph that statement, y equals 1 looks like a horizontal line going through 1. That would be the equation of this line. And if we made a horizontal line as part of the horizontal line test and brought this line down, when it crossed this graph, it would intersect an infinite number of places in this graph. To pass the horizontal line test, it can only intersect in one place. So therefore, that's why this is not a 1-to-1 relationship. In number 6, we're looking at the -1 that is part of this inverse symbol. This is called f inverse. So therefore, this is not an exponent. That's why that's false. Now, when you say the function of f is the inverse of f inverse, that is correct. Usually we start with this value and we say its inverse is this, but these can be switched around and makes a true statement. Now, in this case, G composed of H, and we're thinking of X, that it equals X. It's just a definition if they are the inverse of each other. And we do an example of this as one of our problems, where we say prove that this is the inverse of that. And this is the statement reflecting that. Now in this next part, what we're going to do is have everybody do example 9, where there is our function of f and our function of g, and we first want to do f composed with g when it's 1, g composed of f when it's 1, c f composed of g when we use x, and d when g is composed of f and we use x. So what I'm going to do on our next page is to write this out for you and have you do it as a class exercise. I've set this up for you, so if we don't have it down already, we'll pause and you are to copy this down. Now, when we are taking this type of function, the function of f composed with g, and we're thinking our value of x is 1. In fact, we can put that in parentheses there. What we do is we take this 1 and put it where the x is in g. So I'll write this out in blue. X is 1, so 1 minus 3 is going to give you a negative 2. We now take this 2 and put that where the x is in our f. So x is a negative 2 now. Negative 2 squared plus 1. This is going to be 4 plus 1 equals 5. So this answer is 5. Now what we're going to do is reverse it. We're going to take g composed of f, where our value for x is 1. So we go over here, and I'll go back to, let's say, black, just to make it different. Our x value now is 1. So 1 squared up here plus 1. 1 squared is 1. 1 plus 1 is 2. So we have now, as we start g composed of f, we take the 1, put it where the x is in our f function in black. Squaring 1, we get 1 plus 1 is 2. So this now goes up to this x. This is what we get out of f. We're now going into g as x is 2 minus 3 gives us a negative 1. Okay, so our answers then so far are for f composed with g when x is 1, a 5. G composed of f when it's 1 is a negative 1. Now, one that is often used in these series is to replace values such as these numbers with just the letter x. And we do a similar thing. Now, F composed with G, and we're thinking of X. So this is our G value, and I'll underline that in black, X minus 3. So we then go to our F, and where X is, we're going to put X minus 3 there. That's our X right here, and that's squared, plus 1. Now, we then square this, and that's expanding this binomial. We get x squared minus 6x plus 9, and we bring down our 1 plus 1. This is going to become x squared minus 6x, adding these together, plus 10. So when we have F composed of G, where our value is x, we end up with this expression, x squared minus 6x plus 10. Now we're going to reverse it. We're going to take G composed of F, again using the x. So this is what our F is. The x value for it, we're going to move over here. So this x now, this is our x value for F, x squared plus 2, that we're now going to substitute here. X squared plus 1, I should say. Put that in parentheses. That's our x term, minus 3. So now we clear parentheses and we get x squared minus 2, which is what this one is. Now, an interesting thing happens here. If we take what we had here originally, if we put our 1 into this formula, it should give us a 5. So let's see if that works. This is the proof of the pudding, so to speak. So 1 squared is 1. A negative 6 times 1 is negative 6 plus 10. Well, 1 and 10 are 11. Minus 6 is a 5. So this checks. And for this one, if we put in there a negative 1, x squared is a, well, I'm sorry, we're going to put in there a 1 and see if we end up with a negative 1. So this is 1 that we're going to square. 1 squared is 1. 1 minus 2 is a negative 1, and this one checks. So again, if you want to watch this again, do so. You can rewind and see it. But again, we're stressing this concept of composition. F composed of G, G composed of F, where we're using the value of 1. Here we're using the value of x, and there's the work on one page. Now notice this did take a little bit of time, and it will take time in your practice and quiz me, and if you get one like this on your test. But it's just a matter of protocol following as you go along. And that'll wrap this up.